Hello friends, how are you? I hope you are well. Today in this video I am going to explain the image formation by convex mirrors. In my previous video I explained how to form the image when the object placed at different positions in front of a concave mirror. And one thing is clear that to get the image, we should take at least two incident ray from a particular point. As a result, at least two reflected rays, either they will meet at a point or they will appear to meet at a point. That means we have to draw at least two reflected rays. As a result, we will get the image. But to get the ray diagram, to draw the ray diagram, if we know the behavior of light rays in case of spherical mirrors, then it will be convenient to draw the ray diagram. So for that purposes, we should know certain rules for getting images. So I have written the heading, rules for obtaining images formed by a convex mirror. So, rule number one. What is rule number one? See here. Suppose this is the convex mirror. This P is the pole of the mirror. C is the center of curvature. F is the principal focus. Suppose one light ray comes parallel to the principal axis. If it comes parallel to the principal axis, see that if I draw this normal, it will also follow the laws of reflection. If I draw the normal, that means I have to draw it from the center of curvature. So, this ray will bend like this. It seems that it is coming from the focus. That means I want to say that if a light ray comes parallel to the principal axis of a convex mirror, it appears that it is reflecting from the focus. So first rule is that if a ray of light comes parallel to principal axis of a convex mirror, it appears coming from focus after reflection. That means if it comes parallel, it reflects in such a manner, however, it is coming from the focus. In fact, it is not coming from focus, but it appears it is coming from the focus. This is the first rule I have written. Suppose rule number 2. What is the rule number 2? Just reverse and tell you. This is the pole, this is focus, this is center of curvature. Okay? Suppose a light ray is coming towards the focus. It is coming towards the focus. So, it moves parallel to the principal axis. Listen here. Here it comes parallel to the principal axis. It reflects in such a manner it appears that coming from the focus. But this ray is coming towards the focus. So after reflection it will move parallel to the principal axis. So I can say that if a ray of light comes towards focus of a convex mirror, it moves parallel to principal axis after reflection, just opposite to the previous case. It comes towards the focus, it moves parallel after the reflection. So next one, rule number 3. I hope that you might have noted it. So rule number 3. Rule number, what is that rule? This is the focus, this is center of curvature. Suppose one ray of light is coming towards the center of curvature. If it comes towards the center of curvature, after reflection, it will go along the same path but in opposite direction. You see that this is the point of incidence. Now if I draw the normal, this is the normal. Here angle of incident and angle of reflection both will be equal, that is equal to 0. That means how the light is coming, it will also go back along the same path. So I can say that if a ray of light comes towards the center of curvature, it goes back along the same path after the reflection. This is the third rule. If any ray comes towards the center of curvature, it will go back, means it reflect along the same path but in opposite direction. Next, rule number 4. This is the pole, this is the focus, this is center of curvature. See that? Now, suppose a ray of light incident at the pole. So after incident, it will reflect, making same angle with the principal axis, because the principal axis itself is a normal. This is angle of incidence, this is angle of reflection. All the time it obeys the laws of reflection. So I can say that if a ray of light incident at the pole, it reflects by making same angle, That means angle made by incident ray. So it reflects by making same angle with the principal axis. How much angle made by the incident ray with the principal axis, it will also make the same angle. These are the rules which will help to draw the ray diagram when the object placed at different positions in front of a convex mirror. So let us start the formation of a image. So in case of a concave mirrors, I said 6 different positions. In case of concave mirror, I said 6 different positions. But in this case, only 2 positions are enough. What are the 2 positions? One position, object may be between pole and infinity. Second one is the object may be at infinity. So I am going to say formation of image by convex mirror. Formation of image by a convex mirror. Listen carefully. So first point is object between pole and infinity. Object between pole and infinity. Now you see that. So generally we draw the object in left side. Generally. So this is the focus. This is the center of curvature. This is the pole of the mirror. So object between pole and infinity. See that. This is the object. OB is the object. So I am applying the first rule. A ray comes parallel to the principal axis. Then how it will reflect? It will reflect, however, it is coming from focus. So this is the incident ray, this is the reflected ray. Second one. Now see here. Now this ray is coming towards the center of curvature. In one rule I said, if any light ray moves towards the center of curvature, it reflects back along the same path but in opposite direction. That means this is the virtual. Light ray came here, it goes back, but it seems that coming from here. So here both the extended rays here meeting together. That means this is the place for image. So I can say that suppose O dash B dash is the image. In fact, these two reflected rays appear that they are diverging from this point B dash. So B dash is the image of the point B. I have drawn here perpendicularly because in case of ray diagram, no need. From every point light rays they are going and meeting at line. So I got the B dash, I have drawn the perpendicular. O dash B dash is the image. Now I have used the dotted lines because in fact light rays are not meeting really. It seems they are meeting. So the image is virtual. So what type of image? So I can say that the image is First position. Where is that position? The image between P and F. Between pole and focus. Second point is that it is virtual, erect as it is. The head is up, here and down. Okay, bottom portion here, here. So, as it is in standing, that's why written it is erect. And whatever the size, and it is small in size, so I can write this is diminished. So, the image formed here behind the mirror. That's why it is virtual, erect and diminished. Clear? Next one. Second point is object between object and infinity. I am rubbing it. Second is object at infinity. Object at infinity. So this is the mirror, pole, back side of the mirror, focus, center of curvature. Okay. Suppose the object at infinity, one light ray comes parallel. One more light ray I am taking parallel. Already we know that if a light ray comes parallel to the principal axis, after reflection by a convex mirror, it goes back. It appears coming from focus. This is the case. See that these two reflected rays seems that coming from the focus. That means the image formed at focus. It is behind. In case of convex mirror, you know that the focus is behind the mirror. So I can say that the image formed at F. Image formed at the focus. Which type of image? Virtual. Highly diminished. Okay? Virtual. You can say erect because all virtual image is erect. Virtual, erect, highly diminished. You can say it is in this case, it is like a point image. So these two cases are there in case of the convex mirror. One case is that when the object is between pole and infinity. If the object is between pole and infinity, the image will fall between pole and focus. If the object at infinity, the image will be formed at focus. Both cases, images are virtual, erect and diminished in size. And so far as the distance infinity is concerned, the image is formed, that is pointed size image or highly diminished, I can say. These are the two types of image formation by a convex mirror. Now, one important concept I am going to say, very very important, remember it, that is sign convention. Okay, so before saying the sign convention, I would like to say what are the uses of a convex mirror. Uses. One important is the rear view mirror. That means in our vehicle we use the mirror to see the behind objects. That mirror is convex mirror, because convex mirror can cover a large area, and in a convex mirror the image will be erect as it is. So image will be small, no doubt at all, but image will be as it is in standing manner, and it will cover a large field. So easily we can see the back side objects those are coming. So in case of vehicles we use that is as a rear view mirror, and in case of some cases soft security means in shopping malls, large shopping areas, they use large convex mirrors to keep an eye on the customers. So these are the some of the important uses of convex mirrors. Now let us go to the very important concept, that is the sign convention. Sign convention for spherical mirrors. Sign convention for spherical mirrors means both for concave and convex. What sign convention? When we draw the ray diagram, we found the image at different position depending upon the position of the object. Then how to measure this object distance, image distance, focal length, radius of curvature, height of the object, height of the image. For that purposes, sign convention very essential. Whether we write it is positive or negative. So what are the sign convention rules? So rule number 1, first rule. All distances are measured from the pole as a origin. First point, I am writing a point. So what all distances are measured from the pole of a origin, pole as a origin. For example, this is a convex mirror. This is a concave mirror. This is the focus. This is the center of curvature. I have taken the object here. So the light rays comes like this. This is the pole of the mirror. This is the object. So I shall measure the object distance from pole to object. Pole to object, not from object to pole. Suppose the image format here. Here is the image format. This is the image. This is the pole. I shall measure the image distance from pole to image, not from image to pole. The distance may be same, the magnitude same, but the directions are opposite. So according to Cartesian rule, suppose this is the x-axis, this is the y-axis. Whenever we move towards the right, we take positive. Whenever we move towards the left, we take negative. If you move towards the upside, it is positive. If you move towards the downside, it is negative. If I use this Cartesian rule, then according to this rule, all the time we should place the object left side of the mirror. That means this is the concave mirror. According to Cartesian rule, this is the focus, this is the center of curvature. I have taken the object here. So this is the incident ray, this is the reflected ray. Similarly, This is one incident ray, this is reflected. So this is the pole, this is the object, this is the image. So I shall measure the distance from pole to object, not from object to pole. Image distance I shall measure from pole to image, not image to pole. So first rule I have written, all distances are measured from the pole as a origin. Second rule, what is that second rule? Distances measured along the incident ray. Distances measured along the incident ray is taken as positive. Very, very important concept. Listen carefully. Third point. Okay. Here I can write and opposite to incident ray taken as negative. What opposite? For example, this is a concave mirror. I shall measure the object distance u. U is the object distance. Object is here. I shall measure pole to object. So it is against the direction of incident ray. So I shall take here negative. What about the image distance? Image is here. Real image. Inverted. Now, image distance also I shall measure from pole to image. Pole to image, it is opposite to incident ray. So here also image is taken as negative. Okay. So this is about the second point. Distances are measured along the incident ray. Is taken as positive and opposite to incident ray taken as negative. All the time from the pole. Object is here, I am measuring like this. It is opposite to the incident ray. That is why negative. Okay. Image is here, I am measuring pole to image. It is opposite to the incident ray. So it is taken as negative. Or before that I said that Cartesian rule. What is that rule? Here, whenever moving this side, negative. Whenever moving that's right, positive. Moving left, negative. Similarly, whenever we move upward perpendicular, it will be plus. Downward, it will be minus. Next rule I am writing. So, height of the object or image. Okay. So, you can say that distance measured upward perpendicular to principal axis taken as positive and downward perpendicular to principal axis is taken as negative. That means, see that height of the object perpendicular to principal axis upward means what? Means we consider the height of the object. Here the height of the object is taken as positive. So I can say this is height of the object is positive. Here the image is perpendicular to principal axis but downwards. That means height of the image is negative. So this is the Cartesian rule also. We are following Cartesian rules. Downwards negative, upwards positive. right side positive, left side negative. But according to this rule, all the time we should place the object in left side. Then directly we can apply. Otherwise, if you want to say object keeping mirror, you can reverse it, no matter. Simple rule is that along the incident ray, we should take positive. Opposite to incident ray, we should take negative. Upwards, perpendicular to principal axis, positive. Downwards, perpendicular to principal axis, negative. This is the common rule you can apply, but generally we use the object in left side. This is sign convention. That means it is conventionally accepted. Nothing is there positive and negative. One side we have taken positive, another side we have taken negative. That's why written sign convention. So from this sign convention, I got some important points. What are the important points? See here. In case of a convex mirror or concave mirror, I have drawn the concave mirror. See that. Suppose this is one concave mirror. Okay. In this case, this is the concave mirror. This is the pole. This is the focus. This is the center curvature. Suppose I said object is here between pole and focus. How the image will format? The image will be formed. See here. This is the reflected ray. Now, this is incident ray. This is a reflected ray. These two rays, where they are meeting? They are meeting behind the mirror. So, whenever I measure image distance from pole to image, that means pole to image, this is along the incident ray. I am moving right side. So, the image distance will be positive. But what about the object distance? Object is here. I am measuring like this. This is object is negative. In this case, I said that object distance is negative. Here also object distance I found negative. Here image is negative. Here image is positive. So whenever the image formed behind the mirror, all the time it will be positive. And when the image formed here in front of the mirror, it became negative. So one common thing is that object distance all the time positive. Object distance all time taken as negative. Any mirror, whether it is the concave mirror, convex mirror, does not matter. See here. Suppose convex mirror. This is the convex mirror. This is focus. This is central curvature. Suppose object is here between pole and infinity. This is the incident ray. So this is reflected ray. Similarly, here incident reflected. That means this image formed here. What about the object distance here? All the time we measure from pole to object. This is the incident ray. I am measuring opposite to the incident ray. That means object distance here negative. What about the image? From pole to image, this is taken as positive. So, object distance in both cases, whether incident ray or whether it is a concave mirror or convex mirror, object distance all the time comes negative. And so far as the image, it depends upon the type of the image. Whenever the image formed virtual, definitely it will be erect and back side of the mirror. That means opposite direction of the object. That means it will be positive. Okay, depending upon the position, but all the time we should measure the distances from the pole. So pole to image, image to pole, magnitude same, but different is the direction. So we should measure pole to image. So here pole to image is along the incident ray, that's why it is taken as positive. So this is about the image formation by a convex mirror, as well as I said sign conventions both for spherical mirrors, convex mirrors as well as concave mirrors. So this is for today. So until the next video, bye.